The discovery of K2-18B, a world unlike any other intro in the vast, intricate tapestry of our galaxy, a swirling expanse filled with icy gas giants, scorched deserts, dead moons, and the silence of uninhabited space. There exists one world that simply refuses to be ordinary. Its name? K2-18B. Located over 110 light-years away, nestled deep within the Leo constellation, K2-18b orbits a cool red dwarf star. And while it may appear like just another point of light in our sky, this distant exoplanet may be the closest analog to Earth we've ever found and possibly the first place we detect life beyond our solar system. For years, astronomers noticed strange patterns coming from this planet. At first, it was the presence of water vapor. Then hints of carbon-based molecules appeared, compounds that, on Earth, are essential to living things. But now, with the powerful lens of the James Webb Space Telescope focusing its advanced instruments on K2-18b, we are seeing details that have never been possible before. The data is clearer. The patterns more compelling. And what's emerging isn't just chemistry. It's something that looks a lot like biology. This is not science fiction. This is science. And perhaps for the very first time we are looking at the molecular fingerprint of alien life. What is K2-18b? K2-18b is what scientists now call a Hycean world. The term combines hydrogen and ocean, reflecting a unique class of planets. These worlds possess thick, hydrogen-rich atmospheres and vast, possibly planet-wide oceans. K2-18b is about 2.6 times the radius of Earth, and approximately 8.6 times more massive. So while it's not a perfect twin of our planet, it may offer something even more precious, a stable environment where life could not just survive, but thrive. Most significantly, K2-18b lies within its star's habitable zone, the orbital region where temperatures could allow for liquid water to exist on the surface. Unlike Mars, which is dry and cold, or Jupiter, which is a raging gas giant with no solid surface, K2-18b might be wrapped in a deep, global ocean, sheltered beneath an atmospheric blanket of hydrogen that traps warmth and deflects harmful radiation. In this watery, shielded world, life could find a haven. And Webb's most recent findings suggest that it just might have. The atmospheric signatures: when scientists analyzed K2-18b's atmosphere using infrared spectroscopy, they discovered something stunning, a mixture of gases that on Earth often point directly to biological processes. These gases included water vapor, a sign of humidity in the atmosphere. They found methane and carbon dioxide, both of which are linked to life here on Earth. The presence of these gases, especially in a hydrogen-dominated environment, suggests a non-equilibrium chemistry. In other words, the kind of balance that life often disturbs. Nature, left alone, tends toward stability. But life disrupts that. It breathes, it metabolizes, and it leaves behind molecular traces. Together, these compounds began to draw a compelling picture, a picture that scientists could no longer dismiss as coincidence. The discovery of DMS then came the game changer. In 2025, data from Webb's mid-infrared instrument, MIRI, revealed something unexpected. Among the many carbon-based compounds in the atmosphere was a rare molecule, dimethyl sulfide, or DMS. On Earth, DMS is almost exclusively produced by marine organisms, particularly phytoplankton, tiny, photosynthetic creatures that float near the ocean's surface. Finding DMS on another planet? That's not just interesting. It's astounding. It moves the conversation from, could there be life? To, are we already seeing its effects? But that wasn't the only surprise. The team also detected dimethyl disulfide, DMDS, a more complex compound also tied to microbial life in Earth's oceans. These molecules don't just randomly appear together. Their presence in K2-18b's hydrogen-rich, water-laden atmosphere suggests that something alive, or something very much like life, could be producing them. A planet that breathes? Cambridge astrophysicist Niku Madhusudan, who has led much of the research on K2-18b, has gone on record stating that the data is statistically significant and scientifically compelling. This isn't just a fluke. This isn't contamination. This is a planet that, across vast gulfs of space, might just be breathing. The hypothesis is simple, but powerful. If these compounds are truly biological, then K2-18b may be home to a vast alien biosphere, one composed not of towering forests or giant creatures, but of life, contact, and the meaning of K2-18b. What kind of life could exist there? If dimethyl sulfide, DMS, really comes from life on K2-18b, then that life may resemble Earth's earliest marine microbes, tiny organisms floating in vast oceans, using the red glow of their star to perform a kind of photosynthesis. But some scientists think it could go beyond microbes. Perhaps there are filter-feeding creatures, drifting through rich waters, or even low-gravity organisms that briefly leave the ocean and glide through the thick atmosphere. In many ways, K2-18b may resemble early Earth, when life first took hold and began changing the air. Should we try to communicate? Now that we might have found life, a serious question arises. Should we say hello? Physicist Mark Buchanan says no warning of risks to Earth and the alien world. Philosopher Anthony Milligan says we have a moral duty not to interfere. Others, like Avi Loeb, believe advanced civilizations would have already noticed us anyway. Either way, sending a message would take 120 years to reach K2-18b, and another 120 years to get a reply. For now, we wait. What comes next? NASA and other agencies are now fast-tracking telescopes like LUVOIR and HABEX to monitor exoplanets like K2-18b more closely. Meanwhile, projects like Breakthrough Starshot propose sending microscopic spacecraft to nearby stars using laser sails, possibly reaching K2-18b in 500 years. We may never go there ourselves, but we may one day watch it, and maybe even hear from it. Cultural impact. This discovery isn't just shaking science. It's shaking our view of life itself. Some see it as a sign that life is common, not rare. Others react with skepticism or fear. Social media is alive with theories, excitement, and debate. Governments are cautious, but the public is captivated. Across the world, there's a growing sense that everything has changed. Planetary protection. With all this interest, some scientists warn of the need to protect K2-18b. Astrobiologist Monica Vidari argues we must not contaminate alien ecosystems. There are growing calls to treat life-bearing planets as sanctuaries, places we study from afar without interfering. Even if the life is just microbial, it's still the first alien life we've ever found. And we must act with care and respect. Reflection. What K2-18b says about us. K2-18b isn't just a distant planet. It's a mirror of what Earth once was, a young, watery world full of potential. It reminds us that life is rare, delicate, and precious. And that our planet, too, is worth protecting. Some believe this is a turning point. A moment when science, faith, and curiosity meet. And when we stop asking, "Are we alone?" and start asking, "What comes next?" Conclusion. A whisper from the stars. K2-18b was once just a number on a star chart. Now it may be the first planet where we've detected life. With signs of water, methane, carbon dioxide, and DMS in its skies, the universe may be telling us, we are not alone. It might be the first. It won't be the last. Thousands of ocean worlds wait to be discovered. And as we reach for them, we may not just find life. We may find a new version of ourselves. What do you think? Should we send a message or stay silent? And if we truly discover life, what will it mean for all of us? If this